Alright, all. So, we're going to move on and start chapter 6. We finished talking about fractions. Now we're going to move on. We're going to talk about decimals, but decimals really are fractions, and we'll get to that. But chapter 6.1 is just an intro to it. What is a decimal? So, the first thing we need to talk about is a decimal fraction. So a decimal fraction, all it is the denominator is a power of 10. So you'll see some examples here. Anything along these lines, something like 3 over 10, 3/10, or maybe something like 671 over 1,000, or maybe 55 over 1,000,000, or maybe something like 372 over 100. We could make one of these negatives. Maybe let's make that guy negative, whatever. So these are all examples of decimal fractions. And they're nice because the denominators are all powers of 10, and that means that they'll behave a lot like the way that our place values to the left of the decimal, whole numbers, the way that they operate, which is very excellent. So eventually you'll see that when we do operations with decimals, everything is kind of the same except for a couple of hiccups. So these are all, you can think of them as, all in base 10. So what does that mean? Since adding any 10 unit decimal fractions, and I'll explain unit in a second, so unit, all that means is that your numerator in your fraction is 1. So it's 1 over 10 to the whatever. So a decimal fraction with a 1 in the numerator. So if you add up any 10 decimal fractions, you get a unit fraction of the next largest kind. What do I mean by that? So if I add up 1 over 10 to the k 10 times, so I'm adding that up 10 times. Well, what do I get? I get 10. 10 to the k's, right? The denominator is the same. You just add your numerators. But look, now we have a common factor of 10 in the numerator and denominator, so we can cancel that out. 10 divided by 10 is 1. 10 to the k divided by 10, so that's 1 with k zeros after it. We're just going to cancel out one of those zeros, dividing by 10. This becomes 10 to the k minus 1. So we get a unit fraction of the next largest type. 1 over 10 to the k minus 1. So you can see that addition operates just like addition in whole numbers. If we add up, say, 10 hundredths, we get 1/10, which is pretty cool. And we can think of decimals in a few ways. So remember, equivalent fractions are out there. So that can help us think of decimals in a few ways. So let's take the following example. So this is 32.329. So what does this mean in our notation here? Well, here's 32. We know what that means. But this means 3/10, 2/100, and that's 9 thousandths. The farther you go to the right, the more zeros are in your denominator. So we can write this as, well, this is the same as 32 plus 3/10 plus 2/100 plus 9 thousandths. Or if you like, well, we can get a common denominator for all of the fraction bit. So we can look at this. So this is going to be thousandths would be the least common multiple of 10, 100, and 1,000. So that's the best denominator. So we could think of this, if you like, I'll do this in 2 stages, as 32 plus, well, 3/10 is the same as 300 over 1,000, multiplying top and bottom of 3/10 by 100, multiplying top and bottom of 2/100 by 10 to get 1,000 in your denominator. You get 20 thousandths, and this is just 9 thousandths. Sorry, I should be saying thousandths. And so we can simplify this to 32 and 329 thousandths. That's another way of thinking of it. So we can think of it as each bit of our place value gets separated into different decimal fractions. Or we can make all of the decimal part one decimal fraction. Or we can just do the whole kit and caboodle at once. We can even make the whole part into a decimal fraction. So here, why not make 32? 32 is the same as 32 over 1. So why not make that a decimal fraction with a common denominator as well? So that's 32,000 over 1,000 plus 329 over 1,000. So we can think of this as the decimal fraction 32,329 over 1,000. So they are 3 different ways of thinking about what this 32.329 means. But all we're doing when we're writing decimals is we're writing fractions in disguise. So it's 32 plus 3/10 plus 2/100 plus 9 thousandths. And using the idea of equivalent fractions, we can write that in a few ways. So we can think of, let's do this. Let's do decimals pictorially. So let's say we have the decimal, I don't know, let's do 0.32. So what does that mean? Well, let me draw a unit. It's not a very good unit, but we'll just go with that. So this is 1 unit. We're going to break this up into hundredths. So let me break up my unit into 100 equal pieces. So we'll break it up into 10 pieces. 6, 7, 8, 9, 10. So there's 10 pieces vertically, and let's do 10 pieces horizontally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll just imagine that they're equal. So if we have 32 hundredths, we can think of this, if you like, as 3 tenths and 2 hundredths. So the amount that we have, which I'll do in blue here, is all of this. So there is 10 hundredths, or 1/10, 20 hundredths, or 2/10. There's 30 hundredths and 3/10, plus we have these two here. So this is a representation of 32 hundredths. Let's do one more, just to make sure that we understand what's happening. Let's do something 0. Oh, I don't want to use that pen. I want to use the other pen. There we are. 0.6. So let's do the same thing. I think I should be able to just copy this and keep going. So, did it make a copy? It did. I will drag that over here. And you can see, well, we'll keep going here with the blue. There is 4/10, 5/10, and 6/10. So we didn't even need to break it up horizontally this way. But if we wanted to compare quantities, maybe it's not a bad idea to write this in terms of hundredths. So this is the same. Instead of saying 6/10, we could say that this is, maybe I'll do it in red, this is the same as 60 hundredths. This way it's really easy to compare what's bigger, which decimal is bigger. Well, they have the same denominator. We know how to compare fractions with the same denominator. It's if what has the bigger numerator. And obviously, 60 hundredths is bigger than 32 hundredths. So maybe I'll just make that a little note. To compare decimals. Make them have a common denominator or what that really means in terms of place value is the same places to the right and compare as normal. So you can see up here, I'm going to scroll back up, you can see here we have 0.32, here we have 0.6, and a lot of younger students would say, well, here's 6, here's 32. 32 is obviously bigger than 6, but we know not to do that because we're comparing different size fractions, and we have to make sure that the denominators are the same, and kind of the easiest way is to think about it as having the same number of digits to the right of the decimal. So here is 32 hundredths. We add a 0 to the right of 0.6 to get 0.60, which represents 60 hundredths. Then we can easily compare which decimal is bigger.